Our next speaker is Neel Pandeya. Where is he? Up there. And Neel comes from a company that's probably known to everybody here, from National Instruments, and he will talk about OAI reference architecture for 5G and 6G research with the USRP. Green one, two, four. This is the...
Hi, everybody. Thank you. So at NI, we're looking to find a way to make 5G more accessible on the USRP devices. And we've gotten a lot of feedback from customers and users in the community that there are a lot of challenges with implementing 5G systems on the USRP. And we want to enable that and make that easier for people to do. So we are starting to create reference architecture that will allow users to have a baseline and a starting point for creating these systems. These will be step-by-step guides that will walk you through the process of how to implement an OAI system on the USRP and include all of the steps needed to get there, all the configuration options and things like that, basically to help you accelerate your getting started experience. The USRP N300, the N310, the N320, and the N321, and the X410 will be supported. So those radios will be specifically targeted. And there'll be several UEs that will start, including a discussion about USRP, the Quectel modem modules, the 5G wireless modem module, and the Google Pixel 5 handset. In the future, we'll have additional handsets and modem modules going forward as well. We also, the application notes or the reference design will also include both over the cable and over the air connection. And they'll feature scenarios where you're communicating between devices on the network, as well as those on the public internet. The reference design contains detailed information around performance speed setting, installation instructions, bill of materials, a complete list of all the components you need to implement the system, basically everything you need to get started using the USRP and OAI and the UHD device drivers. It also includes configuration files and some other scripts and automated scripts for automating different processes in the system. The reference design will include instructions on how to operate with multiple UEs, operating on multiple 3GPP bands, different core softwares such as Magma Core, Free, 5GC, Open 5GS in the future. 1x1 and 2x2 MIMO configuration on the G side. Data throughput results with iPerf and other tools to show the performance of the network on the system. Real-time uplink and downlink spectrum monitoring tools that you can use to see the operation over the air or over the cable of your G-Node or UE. The application note is going to be openly published on the Edis Research knowledge base. It's not hidden behind any kind of paywall or something like that. It's openly accessible by going to the knowledge base website. We have an example initial system, and the reference design will be something that's evolving, and there'll be different flavors of it, like I said, depending on the configuration and the USRP being used, there'll be different flavors of the reference system. But one initial system that we have on the first version of this reference design is using an X410 as the G-Node V and a Quectel wireless module as the UE. The documentation describes the systems we used and how we set them up. And the software configuration, in this case, is going to 2004, kernel 5.15 and UHD 4.2, OAI 2022.W3, and a specific Quectel firmware version. And those will change and evolve as time goes on, as new releases of the software come out and things like that. The configuration we use in this initial example system is listed there. The 5G standalone system running with a 40 megahertz channel bandwidth. The sampling rate on the USRP is 61.44, 30 kilohertz subcarrier spacing, 64 QAM, 1x1, band 78 TDD. This is a diagram of the system showing the core network. We're just using the OAI core network on one host. It's connected through a switch to the G-Node V. The G-Node V and the core network system are configured as shown there. using different versions of UHD and Ubuntu and OAI. The system specs are also listed there. Different i9 or i7 CPU computers are used. Then the Export 10 is connected over dual 10 gigabit Ethernet to the host computer, and then over a cable to the Quectel module, which is controlled from another system there. Also running Linux with an i7 CPU. And this software diagram and hardware diagram show you the partitioning of the different components. The core network uses the OAI core network, so the Docker containers are running on one server. The Genome V runs UHD and the OAI software, so that's running on another server, and then that's connected to the GUI running the Quectel firmware. And then a few quick photos of the system at our lab, at our offices, just showing the setup of how we put that together. I'll just go through these quickly for time, showing the different components. And that's it. And then quick slide on how you can get support and ask questions. So come see us at the booth, and I'll be happy to show you more and talk more about it. Thank you.
Thanks.